How's it going, Algebra 1? It is Mr. Knight yet again, and today we're going to look at Level 5, which is combining like terms, and that's going to be our main topic for today. So if you're looking at this, right here we have an expression. Remember, it's an expression if it doesn't have like an equal sign or anything. It's just a bunch of terms that are together, right? A term is anything that is being multiplied together. So it can be this 7x, which is 7 times x. It could be just this 3, just chilling by itself. It could also just be x. It's really any of the terms that are separated by addition, subtraction. We kind of talked about this with distribution. But we have different kinds of terms, right? So if I'm looking at this, I have some variable terms. These are terms with a variable. So in this case, we have 7x, right? It's a variable with some kind of number next to it, but nonetheless it has a variable associated with it. So we have 7x, we have negative 5x, we have also 4x. Those are the variable terms of this guy. But we also have constant terms, terms without a variable. And again, that would be 3, 8, and negative 1. 3, 8, negative 1. Now, the next thing that we want to talk about is this thing called a coefficient. Okay? Coefficients are just the numbers that are in front of your variables. So they only happen with these variable terms. So, for example, the coefficient of 7x would just be 7. Coefficient of negative 5x would just be negative 5, and it would also be the 4. So the coefficient is just the number next to the variable, just for some kind of definition. And we can also combine terms that are alike. So if they have the same variables and they have the same exponents, those are technically like terms. So let's write that off to the side. Let's write that as a definition. Okay? So like terms, they're terms with the same variable and exponents. We're going to see more examples of that as we move forward, but for here, let's just kind of check this guy out. So if we're combining like terms, what we need to do is we need to see which ones have the same variables. So for example, 7x is a like term to negative 5x, is also a like term to 4x. They all have an x variable with them, and so to combine them, we just add and subtract their coefficients, the numbers that are in front. So it's just like addition, subtraction. So I do 7 minus 5 is 2, plus 4 is 6. So that would be 6x, right? I just combined with addition, subtraction, what the coefficient would be. And then for these guys, I look at the constants. These are all like terms because they don't have a variable associated with them. So I go 3 minus 8, which is negative 5, minus 1, which is negative 6. So this is 6x minus 6, as simplified as possible. And that, ladies and gentlemen, is the essence of combining like terms. You could just simplify what your expression is going to be like. So we got a couple examples below right here. All right. So let's try something that's kind of hard, or that looks harder than some of these guys up here. So for example, let's look at number 7 right here. Okay, we got 5x plus 7y minus 2y. Oops, sorry. 5x plus 7y minus x plus 2y plus 3x. So how I do this is I underline all my like terms. I keep the signs too. I do that as well. And then since they all have the same terms now, I just get their coefficients. Well, this guy right here, if it doesn't have a number or a coefficient on front, and it's just like this, it's assumed that there's a 1 out in front. So keep that in mind. So we're going to do 5x minus 1x plus 3x. So we will get 5x minus 1x is 4x, plus 3x is 7x. And now we're going to double underline all the different terms. So the 7y, its like term is this 2y. And now I'm going to add them because there's an addition symbol in front. and I'm going to do 7y plus 2y, get 9y. And that is as simplified as I possibly can get. Okay? Not too bad. Not too bad. Let's see it with number 8 now. Let's do another one like this. Number 8. So we have 26a. And then let's find the like term of that. That's going to be this negative 4a. So 26 minus 4 is 22. And then a. And now we have 2b, or not to be. That is the question. 2b plus 10b, we have 12b right there. And that is as simplified as we could possibly get with combining like terms. And that's all there is. So now that you've seen a couple of examples, let's do a couple of you tries on your own. I would like you guys to do number 5. And I'd like you to do number 6. Go ahead and give those two a shot and go. Alright, we're back. Let's see what you guys got. So we have 7p minus 9p. We have 7 minus 9, so that's going to give me a negative 2p. And then we have negative 1 plus 5. That's going to give me a plus 4. So really it's your signs that are going to trip you up. So if you have that sheet that I gave you guys with the rules of addition and subtraction, that's probably going to come in handy for this lesson. So right here we have 5h plus 7h. That'll give us 12h. And then we also have negative 6 minus 8. The signs are the same, so we're going to add 6 and 8. We get 14. And since they're the same sign, we're going to just keep the negative. And we get minus 14. All right. Let's see a couple more examples on the back. This time we're going to deal with exponents. So we're looking at this now. So again, like I was saying, terms with the same exponents or combination of variables and exponents are considered like terms. When we combine them, we're not going to change their exponents, just like we don't change their variable, right? So we're just adding the coefficients again. So for example, if I had something like 2x squared, a like term of that would also be like 5x squared. But 5x by itself would not be a like term, okay? Because it doesn't have the same exponent with its variable. So let's apply that to number 13 and 15 right here. We're going to do these two examples. Let's kind of zoom in on that. So number 13, we have negative 4a squared b plus 7 plus 10a squared b. So let's start with this first term right here. If I have negative 4a squared b and I add my 10a squared b, I'm going to end up getting 6a squared b, because those guys are like terms, and then I'm just left with plus 7. Okay? Nothing different than what we were doing before. Now we're just dealing with exponents and realizing that just because they have the same variable, if they have different exponents, that is what makes them unique terms, right? So you can't combine an x squared and an x through addition and subtraction. 15, let's see, with a squared, do I have any like terms with that? It doesn't look like it, so I'm just going to write it down below like that. And you could cross them off as you go too. There's a lot of ways to strategize here. We have this 7ab right here, and then we have a like term which is negative 10ab. Okay, so 7 minus 10 is negative 3ab. And then we're left with just b squared, and it's a positive b squared. Okay. You can also have combinations of variables too. So if it's just 2a plus 2ab, you can't combine those because those terms have different variables associated with them. Okay? I just said difference. That's not even a word, man. 14 and 16, I would like you guys to try these on your own. I'm going to come around and check and go. All right, we're back. Let's take a look at this. X squared doesn't have any other like terms, so I'm going to plop it down. We got 2xy minus 7xy. That's going to give me negative 5xy. And then finally, the 4y squared. It's all by its lone self. And we're all done. 16. Anything with 4x squared? Yes, negative 3x squared. We do 4 minus 3, we get 1x squared. But remember I said if it has a 1 in front of it, it's also the same as just having your term without the 1 in front of it. So this is implied that there's a 1 right there, so that is good. Let's move on. Negative 7 minus 6, that's minus 13. And then finally 2x plus 8x, that gives me plus 10x. And we are done. All right. Now finally, our last thing that I want us to go over is an actual geometric application. So now we're going to think back to what we know about perimeters, and we're going to use that to help us rewrite an expression and simplify it as much as possible. So for example, if we have number 19, let's check this guy out for a second. Number 19 says, give the perimeter of each figure as a simplified expression. So what do we know about a rectangle? Well, if we have a length and a width, I could also say that my widths are going to be the same, right? So this side is also y plus 2, and this length is also 3y minus 5. So now, what do we do to find perimeter? Well, we add up all the sides, and that's exactly what I'm going to do. I'm going to do 3y minus 5 plus y plus 2 plus 3y minus 5 plus y plus 2. And there's a lot going on right there, so let's try to clean this up, right? We might have to go off-roading off this page. So I got 3y plus y plus 3y plus y. That's going to give me 8y. Cross them off so I don't have to look at them anymore, and I can just focus on the constants. We have negative 5 plus 2. That's going to be negative 3. Minus 5 is negative 8. Plus 2 is negative 6. So 8y minus 6 is the simplified version of this rectangle's perimeter. The reason we're going over this is because there is a challenge problem on your homework, and I'd like you to at least have the tools to attempt it. So now I'd like you guys to try this last one. I want you to try number 17 on your own. I want you to give me the perimeter as simplified as possible by combining like terms, and go. All right, we're back for our last one. So I'm going to do 2x plus 1 plus x plus 3x. Let's combine terms. So 2x, x, and 3x are all the same terms. So we have 2x plus x is 3x, plus 3x is 6x, and then we just tack on that plus 1. And we're done with that guy. All right, good luck on your homework, and I'll be walking around helping you. And if you're at home, have a good day.